the first definition of the trigonometric functions we'll talk about involves x, y, and r. If you remember, the initial side is along the x-axis, and we're going to draw a right triangle here. The terminal side is from the origin to the point. So this is r, and this is y. Okay, notice your definitions. Sine of theta is y over r. Cosine of theta is x over r. Tangent of theta is y over x. And if you notice, I've written that the denominator can't be 0. So tangent and cotangent are reciprocal functions. Cotangent of theta equals x over y. Secant of theta equals r over x. And cosecant of theta is equal to r over y, where r is equal to the square root of x squared plus y squared, which we're doing distance formula. So let's look at some examples. Find the 6 trigonometric functions of theta. Theta is in standard position. You have the point -2, 3. Okay, that'll be your terminal side. You always go from the origin. Drop it down perpendicular. So this is -2 and 3. Now, mathematicians don't like to see the -2 because technically we're talking about distance. So let me come over here and put -2 and 3. So I'm going to erase that negative sign here. Let's just put 2 because you're 2 units to the left. Then r is equal to the square root of -2 squared plus 3 squared. So r is equal to the square root of 13. Now, we could rationalize. It depends on what the professor expects. So in the trig class, in the book we're using, sometimes the author does and sometimes the author does not. So let's go over our trig functions. So sine of theta, which is y over r, is equal to 3 divided by square root of 13. Cosine of theta, which is x over r, is equal to -2 over square root of 13. Don't forget what sign you need to use. Tangent theta, which is y over x, is equal to 3 over -2. So we're going to put the negative sign either in front, which is best, or in the numerator. Now, the reciprocal functions, we'll do those in blue. Reciprocal sign is cosecant, so that's r over y, or you could just flip it, root 13 over 3. Let me move that r value over here. So r is equal to the square root of 13. Okay, flip cosine, and that's secant. Secant of theta is equal to root 13 over 2, and that's negative. And cotangent of theta is also negative. -2 over 3. Okay, there are 6 trigonometric functions of 270. So if you graph where 270 is, that's 90, 180, 270. So that goes right here. That's your 270 degree angle. Okay, so we're going to go with that point being 0, -1. So r is equal to the square root of 0 squared plus -1 squared. So r is equal to 1. So sine of 270 is equal to -1 over 1, which is -1. Cosine of 270 is equal to x over r, 0 over 1, which is 1. And tangent of 270 is equal to -1 over 0. You're not allowed to divide by 0, so this is undefined. Okay, cosecant of 270 is 1 over -1, which is still -1. Secant of 270 now is 1 over 0, which now secant is undefined. And then cotangent of 270 is equal to 0 over -1 equals 0. Okay, so if sine 5 over 13, if sine of theta is equal to the ratio 5 over 13, and theta terminates in quadrant 2, find the remaining 6 trig functions. So first let's draw a picture. So this is 13 is our r, 5 is here, we need x. So I know that x squared plus 5 squared equals 13 squared. X squared plus 25 equals 169. X squared equals 144. X equals 12. So again, sine of theta is equal to y over x, so that's going to be 5 over 13. Now notice you're in quadrant 2, so really the point should be -12, 5, and r equals 13. Cosine of theta is equal to -12 over 13. And tangent of theta is equal to -5 over 12. Cosecant of theta is equal to 13 over 5. Secant of theta is equal to -13 over 12. And cotangent of theta is equal to -12 over 5. So I want you to go and try some problems on your own. Have a great day.